this is section 5.1, angles and their measure. We are starting trigonometry. Our objective is to know how to change from radian to degree measure and vice versa and find both coterminal and reference angles. First of all, it says an angle with its vertex at the origin and its initial side along the positive x-axis is said to be in standard position. Positive x-axis is here, and we always measure our standard position angles up like this. And if you'll look at your unit circle, which is blue, you can notice that all my angles, it starts at 0 and it counts. Here's 30, 45, 60, 90, 120, 135, 150. Halfway is 180, which should make sense. 180 degrees is halfway. And then this 210 on this one is in the wrong place. I can't keep counting around. 210, 225, 240, 270, 300, 315, 330, all the way back around to 360. 360 is the whole circle, 360 degrees. And basically you have 0, 0, 90, 180, 270, 360. So if you have an angle that's between 0 and 90, it's going to lie in quadrant 1. Between 90 and 180 will be in quadrant 2. Hopefully you remember these from Algebra 1 geometry. 180 and 270 will be in quadrant 3. And between 270 and 360 would be in quadrant 4. Okay. Now we want to look at changing degrees. This is called degrees. The second one is minutes. You don't see this a whole lot, but you do see it in latitude and longitude and seconds in geography, as well as it's used, pilots use it to fly planes, and my husband says he's used it, he teaches machine tool. He sees it, degrees, minutes, and seconds sometimes. It says to a decimal number of degrees to the nearest thousandths. Well, it works just like time. It's your degree plus the number of minutes. You divide it by 60 because there's 60 minutes in an hour, there's 60 minutes in a degree, and then 26 seconds, whoops, just kidding, we're doing it broad, divided by 60 times 60, which is 3,600. So we'll do 29 plus 45 divided by 60 plus 26 over 3,600, and we can just stick it in our calculator. So it would be, I don't remember, curses, 29 plus 45 over 60 plus, 26 over 3,600. You want to get a decimal, so control enter. 29.757, so that's the same as 29.757 degrees. And we're going to define something new. It says an angle of one complete revolution can be represented either by 360 degrees or by 2 pi radians. This is a new unit of measure. Think about, like, we measure things in feet, but Europeans measure things in centimeters, or you could say pounds and kilograms, or miles and kilometers. This is just a different unit of measure. It's another way to measure an angle. It says, thus the following formulas can be used to relate degree and radian measure. Now, radians, everything in calculus is in radians. We do not use degrees at all. So we're going to start out converting degrees to radians, but then after that, every answer should be in radians. We will not use degrees. So what it is if you have a circle, here's 0. All the way around the circle is 360 degrees. Or all the way around the circle is 2 pi radians. Especially if you'll notice on your unit circle, the unit circle has a radius of 1. Okay? So I want you to think about if you found the circumference all the way around the circle, all the way around. the circumference is 2 pi r, but in the unit circle, the circumference is 2 pi times 1, so it's 2 pi. It's all the way around. And the radian is actually the distance along the outside, as well as the angle. So if that's 2 pi, halfway, let me flip back over here, halfway would be 180, or 1 pi, okay? Halfway to pi would be 90, halfway to 180, or pi over 2. So these are just a few of our radians, and if you notice your unit circle, everything on the outside, these are our radians. Pi over 6, pi over 4, pi over 3. Notice they correspond with a degree. Okay, pi over 2 goes with 90, 2 pi over 3 goes with 120, 3 pi over 4 goes with 135, and so on and so forth. Please note, you are going to have to memorize the circle, and I'll show you easy ways to memorize it. Don't let that freak you out. Okay, so here we go. To go from degrees to radians, you multiply by pi over 180. To go from radians to degrees, I just got a text. You multiply by 180 over pi. I'm trying to turn my phone on vibrate. Hold on. Okay. You multiply by 180 over pi. Now you can remember that because if you want to be in radians, all the radians have a pi, so that's what you want on top. If you want to be in degrees, if you want your answer in degrees, you want the degrees on top. So it says change, and the word, should be degrees to radians. I'm not sure if it's a typo on yours or if I remember to fix it. So you do 30. To go from degrees to radians, you multiply by pi over 180. Okay, that gives me 30 pi over 180, and then I have to simplify my 30 over 180. Well, 3 goes into 18 6 times, so that's 1/6. So my answer is pi over 6. If you type it in your calculator, you have to do divided by 180 and hit enter. Don't type the pi in. It'll give you 1/6, and you just put the pi on top, but we're not going to be able to use our calculator, so you need to do it without. So we want 45 times pi over 180, so that's 45 pi over 180. 45 goes into 180 4 times, so it's pi over 4, because we're just simplifying the 45 over 180 to the 1/4. And then this one should say change to degrees. It's another typo. To change to degrees, we multiply by 180 over pi, because we want the 180 on top. So multiply by 180 over pi. The pi's are going to cancel out. And that's our goal. We want to get rid of the pi's, because in degrees you don't have pi's. So you do 3 times 180 divided by 4. And I'm going to cheat, just because I don't know. 3 times 180 divided by 4. For right now, we can use our calculator for the big stuff. It's 135 degrees. Try this one by yourself. Pause me and then come back. Pi's cancel, so you do 7 times 180 times 180 divided by 8. Control enter. Whoops, I did it twice, didn't I? Whoa, what just happened? Escape. Hold on. We're freaking out here. It's this answer. Control enter. Watch out that you don't accidentally divide by 8 twice. So that's 157.5, and that is degrees. It says two angles in standard position are called coterminal angles if they have the same terminal side. What that means is, if you think of, let me get a circle filled with white, with, well, I did not want a black circle. Oh, I know why. I want a black circle with a white inside. There we go. Get rid of that. Here's my circle. let's just say, I want you to pretend for a second that your circle is like a tire and it has a nail in it. Okay? Let's see if I can, okay. If I spin my circle and I go right back to the same place, is my nail in the same place? The answer is yes. What if I spin it the other way? My nail's in the same place. That's what it means to have a coterminal angle. You can go around and around and around the circle either way you want to, as many times as you want to. Okay? You might have, let's see, if I think about my circle, this is 0. It's also, if I go all the way around, it's 360. If I go around again, it's 720. If I go around again, it's whatever 720 plus 360 is, 1080. Okay? Or I can spin the other way. I can go this way and it's negative. If you spin it the opposite direction, it's a negative. I can do it again. I'm back to where I started. I'm at negative 720, and so on and so forth. So, whoa, I didn't want to do that. Let's just refresh it to here. It says find one positive and one negative coterminal angle. So what I want to do is I want to spin all the way around my circle one time. Well, what is all the way around my circle? 2 pi. So if you're in radians, you want to stay in radians. If it gives it to you in degrees, you want to stay in degrees. So to find a positive coterminal angle, all I do is add 2 pi. And we can just type that in our calculator for, no, we're not. We're gonna get good at actually doing stuff. So if we add 11 pi over 4 plus 8 pi over 4, because that's getting a common denominator, I would have 19 pi over 4. So there's a positive coterminal angle. Well, how do I get a negative coterminal angle? Well, I would subtract minus 8 pi over 4, and I would get 3 pi over 4. Okay? That's not negative. However, I now have 2 positive ones. So I take my 3 pi over 4 that I just got, and I subtract it again. What am I doing? I'm spinning my circle twice in a negative direction. 3 take away 8 is negative 5 pi over 4. So you just do it until you get one positive and one negative. Now, if you're smart, did I have to add at all? No, I didn't. All I had to do is, if I'd have subtracted the first time, I would have had a positive. Subtracted again, had a positive. I'm done. So if it's a positive, just start out subtracting, and if you hit another positive on the way, you're good. So I'm going to start out subtracting, and my common denominator is 4, so I'm going to subtract 8 pi over 4, because that's the equivalent of 2 pi. 13 take away 8 is 5. There's a positive, so check. Now I'm going to do it again. I'm going to start with the 5 pi over 4, and I'm going to subtract 8 pi over 4. 5 take away 8 is negative 3 pi over 4. I now have a positive and a negative. I'm done. So try C. Pause me. Okay, I'm going to start out subtracting, and it's over 2, so it'd be 4 pi over 2, because that's what would reduce to 2 pi. So that gives me 5 pi over 2, so there's a positive. I'm going to subtract again. There's another positive, 1 pi over 2. So I've got to keep going until I get a negative. Minus 4 pi over 2. That's going to give me negative 3 pi over 2. So there's a positive, there's a negative. Now you could use this one, you could use this one, and if you wanted to be really mean to me, there's an unlimited amount. I could keep going. I could subtract 4 pi over 2 35 times and get that answer, and that be my answer. Or I could add 4 pi over 2 10 times and use that answer. But just to be nice to me, just find the easiest ones so it'll be easier to grade and I don't have to figure out if you're right. You'll get your papers back faster that way. And then it says identify, ignore the word all. Let's just do one positive and one negative again. Okay? If it's in degrees, all the way around my circle is 360. So I simply add 360. And then I subtract 360. 60 plus 360 is 420. 60 minus 360 is negative 300. And there's my answers. I have one positive, one negative. So I add 360, and I get 405. And I subtract 360. Ooh. Negative 315 maybe. 90 plus 360 is 450. 90 minus 360 is negative 270, I believe. And then the last thing we're going to talk about today is reference angles. It says it's defined as the acute angle formed by the terminal side of the given angle and the x-axis. It is that, but the easiest definition of a reference angle I can give you is the distance, and it's the positive distance, because distance is always positive, to the closest x-axis. Okay, so let's just pretend if this is a 45-degree angle, then that's 45 degrees. Okay, let's say this is 150. Just pretend for a second. That's 150 degrees. Well, the closest x-axis is 180 degrees, so that distance would be 180 minus 150, which is 30. If I'm in quadrant 3, let's call that 200. Pretend it's 200 degrees. And this is 180 degrees. Well, the distance here would be 20 degrees because it's 200 minus 180. That's what this little theta minus 180 is. It's just like a guide for you. And then if this one was 340, again, it would be 20 degrees because the distance to the closest x-axis is 360. Now, your tendency is going to be to try to go to 90 and 270, but never go there. It's not the distance to the closest y-axis, it's to the closest x-axis. Okay? It says find the measure of the reference angle for each angle, and I will tell you these are easier to find in degrees. This is the only thing that I'll let you start out finding them in degrees. Eventually we're going to go all radians, but for right now you can put them in degrees. And then just convert it back to radians at the end. So we're going to convert this to degrees. Okay, so I'm going to use my calculator on this part. 5 times 180 divided by 4, make sure you hit Control Enter, and I get 225. So I'm at 225 degrees. So I sketch it. That's 0, 90, 180, 270. 225 would be here. The closest x-axis is there. So I do 225 minus 180, and I get 45 degrees. I need to then convert that back to radians times pi over 180, and I get pi over 4 as my reference angle. And if you look on your circle, and we look at, what was it initially? 5 pi over 4. Now all of them aren't on your circle. 5 pi over 4 is here. And if you look at this distance, and you go straight across to the other side of the circle, and you look at this distance, notice that they're the same. Okay? That's what a reference angle means. What angle does it correspond to in the first quadrant? 7 pi over 8. I'm going to convert that to... Why am I writing with a highlighter? Stop it. Times by 180 over pi. So 7/8 times 180 is something. 157.5. I feel like I've done this already. 157.5. What quadrant is that in? Well, it's between 90 and 180. And you want the distance to the closest x-axis. So we would do 180 minus 157.5, and I think that's 22.5. If I then convert that back to radians, and I do 22.5 divided by 180, I get 0.125. To convert that to a fraction, I'm not 100% sure. Do 125 over 1,000, and you get 1/8. Because it's in the third decimal place. I'll get back with you on how to convert to a fraction. I'm not not 100% sure how to do that. So pi over 8. Now if you notice, with the radians, something nice occurs. Very, very nice. Just keep watching. Now, negative 13 pi over 3, I don't know, well, first of all, let's convert it to a degree. Negative 13 over 3, negative 13 over 3 times 180. Negative 780. Now, negative 780 is not on my circle. Okay, so what can I do to get something that is? Well, I can add 360. So plus 360. Get a coterminal angle. Well, it's still not on my circle, so I add 360 again. Still not on my circle, so I add 360 again. And I get 300 degrees. So I added 360, I think, 3 times. And I got 300. 300 is here. The closest x-axis is 360. The distance is 60 degrees. 60 degrees, if you convert it back to radians, is pi over 3. See if you see a pattern forming with these reference angles. 510 is too big to be on my circle, so I subtract 360 to get something that's on the circle. 510 minus 360 is 150. Okay, 150 is here. 180 is here. The distance is 30 degrees. So my reference angle for 510 is 30 degrees. 425 is again too big for my circle. If it's too big, you subtract 360. If it's too small, you add 360. So I do 425 minus 360, and I get 65. So 65 is in my first quadrant already. The distance from 0 to 65 is 65. So my reference angle here is 65 degrees. And I'm going to cheat just a little bit on F. You should have saw a pattern on the ones that are pi's. It's going to be pi over 6. You can work it out and prove it to yourself, but the answer is going to be pi over 6. And that is all. That completes section 4.1.